All right.
Okay, we are.
And here we go. We're getting on with our next talk, which is with Ginji here. Do remember that the conversation with the talks is happening in our Discord, which there's a link to below the stream. And the channels that are specifically related to this talk are the ones that are called getting getting a pulse on your fit Bytes. And so there's a talk channel and a talk QA submissions where you can submit questions for the end of the talk. So with that, I'm going to turn it over to Ginchi, and here you are.
All right. Hi, everyone. My name is Hacking Hyena, Ginji Terrano. I am Lobstar85 on Twitter, and this talk is about getting a pulse on your Fitbytes. So, to start out, a little bit about who I am. Obviously, I'm a hyena at heart. Uh, I love video games. I run Menchi.org, which is pretty much an homage to my dog, Menchi, and you'll see lots of pictures of him on there too. But it also has pieces of my portfolio and several servers and services that I've written that I'll be talking about in this talk. I used to be about 500 pounds. I was really, really fat, like this 55 megabyte presentation. In fact, if you tried to fit this presentation on a floppy disk, it'd work pretty much as well as me fitting into my current size 38 pants. So I knew it was bad, and I needed to drop the weight. I ended up losing about 300 pounds without any weight loss surgery whatsoever. So to get started, the standard medical disclaimer. Don't attempt to do any sort of radical weight loss without at least consulting your doctor or a medical professional so you don't hurt yourself. A healthy lifestyle incorporates both a good diet and exercise, and you should never neglect one over the other. All right, so what is this talk not going to be about? Well, as I just said, weight loss comes from both exercise and diet. I could go on a whole other diatribe about how I scienced the shit out of my diet to get it to work for me. But the fact of the matter is, I had to completely overhaul my relationship with food and my diet into everything you see here. So the TLDR is there's a lot more to weight loss than just this singular component. You're going to have to change your entire lifestyle if you want results. So to start out, we have our roadmap, a window to weight loss. Hi, Dr. Nick. I took the liberty of outlining some of the steps I took to find activities that I like to do and try to measure their effectiveness. So if you get the pun down below, we're going to find and break down these desirable activities and find the ones that are most effective. So if you pardon the other pun, ABBA, I am a dancing yeen. As a pup, I loved Dance Dance Revolution. I loved it so much that when given the opportunity back in 2015, I went out and bought one of the most kick-ass ones you possibly could. It was a Japanese black high definition deluxe DDR machine. It had all the light spires and RGB lighting, integrated card readers, USB, keypads, extra buttons, the works. Then I went ahead and put it in a public arcade so that everyone could enjoy it, but mostly because I couldn't fit it in my house. Something else to keep in mind for later is that this arcade was a little bit far from my house, about an hour. So just remember that. Um, I wanted some insight to how to best tailor my play sessions and get the most out of them. I mean, it is exergaming after all, so why wouldn't I? I know I'm highly motivated by numbers and goals. So with all of this, how do I hack my life and get it back on track? So as soon as I got the machine, I quickly found out that playing the same songs in one version of the game over and over kind of got old and boring. And there was a bunch of older songs that I really missed. I needed some variety. So I thought to myself, why settle for just one game when I can have them all? So I obtained several other instances of the game and installed them inside of my cabinet. Then I linked them all up to work through an online game selector. I created an application on my phone where the user would just scroll through, select the version of the game they wanted to run, click it, and then just reboot the cabinet, and ta-da, there it would be. I then gave this application to the front desk staff, and now anyone can walk into the arcade and ask for any specific version of the game to play. So it was a win-win. I got a bunch of variety, and everyone got to play the versions of the game they enjoyed. So let's take a look at our roadmap. We found an activity that I love without even really trying. Dance Dance Revolution. Great. And we can play all the games. So let's get the best data we can out of it. In order to do that, let's look and see what data the game can provide us already out of the box. Well, most versions of the game can track your calories based on the steps or how many times you trigger the panel during the song playing. However, it calculates your calorie burn based on that of a 115-pound tiny Japanese person. And I'm this hulking 500-pound sumo wrestler kind of guy. So I thought, well, that can't be right. Thankfully, newer versions of the game are networked, and that means that players can have online profiles. A player can save their weight to these profiles, and the calories are then scaled accordingly. That data can then be saved on their online profile and viewed historically online. If you take a look to the right, you'll see the interface for the cabinet for being able to enter in your weight so that you can scale that calorie burn. Something else to keep in mind was the game was also in Japanese. I managed to do a quick translation of it, so pardon the typo. But the important part here is demonstrating the calorie burn. See, at the end of every song, it would tell you how many calories you burned during that song. And it also told you how many calories you burned during a session. Um, you'll also see right below that is a equivalent food that you would have burned. Now, there's some very interesting Japanese foods in there that most people over here would have no idea. For example, they would know what katsudon or yakitori is. So I looked up calorie equivalents of standard American foods and put them in there as well, so that people would actually have some sort of basis for comparison like they would with some of the other non-standard ones. So in order to accommodate all of this, I had to obviously implement my own online network. And I happened to be the only one that really cared about focusing about these workout mode features. Most other people were concerned about saving their scores, setting records, finding rivals, etc. So after I implemented my own network, I was able to save the data historically and create a web interface that allowed for data export of these sort of calorie features. And you can see a rudimentary graph that drew in real time while I was testing this. So as time went on, things got a little annoying. As you might imagine, adding a bunch of activity at that size, I was losing weight pretty fast. I lost 200 pounds in the first year alone, and close to another 100 pounds in the second year. So that meant I was entering weight in all of my services, such as the DDR game or MyFitnessPal, almost daily. So I thought, there's got to be a better way. This is really annoying. And luckily, there was. So we already know that I was a pretty big guy, but I didn't know how big I was until I got a scale that could actually tell me how big I was. So I decided to get this A&D medical scale. It just so happened to have Bluetooth Low Energy built in. So I thought to myself, what if I could use this Bluetooth Low Energy to update my weight in all these places? This was my first exercise. Get it? So let's learn a little bit about how Bluetooth Low Energy works. But first, there is a little bit of a difference. Bluetooth Low Energy is not the same as regular Bluetooth. It's kind of like the same branding and frequency, but it works very differently. So if you're familiar with Java versus JavaScript, it achieves similar ends, but works totally different. You see, Bluetooth is profile-based. It's used for transferring large amounts of potentially continuous data, like audio streams to your headphones. It also noms your battery, and depending on the chip, can cost a lot more. Bluetooth Low Energy is client-server oriented in a sense. It's constantly in sleep mode until it's told to wake up and actually do things. It's got shorter, smaller bursts of data, so it can go a further distance because it's got built-in data parity to help accomplish this. So, understanding that, let's go over a very brief, oversimplified workflow for Bluetooth Low Energy. A client, such as a phone, will connect to a GAT server, such as a peripheral. And GAT just stands for generic attribute, so don't let that trip you up. The client then enumerates all of the services on the server, and each service can have read or write permissions. The client then selects the service it wants to connect to. The client performs its read or writes to that service and can even subscribe to updates like push notifications. Then the client disconnects when it's done. Pretty simple, right? Luckily, the Bluetooth SIG has some standardized services. Um, Services are given special reserved names and accesses. I'm sorry. Adjust the mic. Okay. Sorry about this, guys. Okay. So some of these servers and some of these services are standardized, and some of them even have specialized ways of talking, predefined, such as heart rate monitors, scales, etc. And if you're interested in seeing the full list of these, you can check out the Bluetooth SIG's GAT services specifications page. As my luck would have it, though, my scale was non-standard. It supported multiple people weighing in, and the standard actually didn't only supported a singular person weighing in. But I was very lucky that the manufacturer had a GitHub account that explained how to interface with my scale, so it was pretty easy to get started. So as soon as I did that, I wrote an app, and yata! No longer did I have to use manual entry on my web page to update my weight in DDR. And we're tracking the calories and my weight loss according to the data the game is sending right up. Other services also got the weight update as well. Where possible, I used APIs, but a lot of times there are no free APIs or available APIs for you, so I use JSoup or Beautiful Soup to parse the web forms and perform the updates myself. Well, back over here, we know DDR track calories. I wasn't exactly thrilled with that metric, but I mean, it worked. So, is this really the best means of exercise measurement? Well, no. I decided I wanted more data. We know DDR calculated its calories based on your weight and the steps it observed. And if you triggered more than one panel, it thought you jumped. So it would give you a little calorie boost. But everyone plays different. Maybe you've seen people in the arcade holding onto the bars and fluttering their feet like a hummingbird. And then maybe you've seen people dancing around like they're in a drunken stupor on the dance stage. How could the game possibly know and take all of that into account? So, how could I make it better? Ah, uh, thank you. So I had to find my rhythm. I think my audio dropped. Can you guys hear me? I should be okay. Um, so I had to find my rhythm. I know that calories are best estimated by measuring heart rate. So was there a way to measure my heart rate and get that calorie information? Uh, the answer lies in chest straps. So chest straps are among one of the most accurate heart rate monitors out there. They're a cheap, established standard with a wide variety of fitness integrations. And it was something new to program for. But the only non-starter for me was that it didn't work on my phone, which was a Moto Z2 Force. I know some Samsung phones have Ant Plus services, but they're more the exception rather than the rule. So there is another alternative, though. There are Bluetooth Low Energy chest straps, which have all the advantages of the Ant Plus chest straps. And I've coded for Bluetooth Low Energy before. On top of that, it was a standardized service based on the Bluetooth SIG information as well. Plus, they come in pretty colors, but no one's ever going to see them unless you're playing shirtless. And no way in hell I was playing shirtless. They're also a little bulkier, and I'd have to remember to bring it with me on location. Remember, it was an hour away, and I was kind of screwed on getting that better data if I forgot it. They were also a lot more expensive than their Ant Plus brethren, and they ate batteries for breakfast. So I thought there had to be a better way, and there was. You see, I had a Fitbit because I was tracking my steps already to make sure that I was getting enough movement throughout the day. And the Fitbit, in addition to steps, can track your heart rate, distance, calorie information, active minutes, and more. And it can do this all in real time without a connection to a server, which is what I wanted to use. Plus, they came in pretty colors, like purple, and people are actually going to see that. So clearly, I can rock my style. And bonus, I'm already wearing it, so it's not like I'm going to forget it. So I already had experience with Bluetooth Low Energy. How hard could it be to implement this? So I looked at the Fitbit API that they provided, but it wasn't real time. What actually happens is Fitbit sends a giant blob of historical data to your phone. Your phone then processes it and sends that data up to the cloud. The cloud then needs to process it, and something requests that process it data. I didn't want that kind of delayed information or a server in between. I just wanted the watch to tell me the data in real time like their app did. I had ideas. I wanted to see my heart rate on the screen while I played the game. Tell me when I'm in the zone. I wanted to use that calorie information from the Fitbit instead of the game calculated calories as well. So I had to use my own server and add some APIs to allow for this sideloading. After I added the requisite APIs, I wrote a quick application and stubbed out where I expected to be able to listen for the data on the Fitbit, pushed some test data into the new API, and associated it to the appropriate problem, and I was pretty much set. Now, to focus on the Fitbit. Sadly, it didn't work at all like you might expect after working with the scale. So the Fitbit is the clear winner for the better data, but we had to make sure that I actually am able to do anything with this data. So where do I get started? Well, first I thought maybe, for the hell of it, it did use standard services, but no, it didn't. So not wanting to have to reinvent the wheel, I saw some work being done on the legacy trackers, like the Fitbit Zip. Google revealed something called the Galileo project, and it had a little bit of multiple communication protocols from Fitbits documented. However, it was focused on that mega dump format, the thing that sends those giant blobs of data from your Fitbit up to the cloud. So it wasn't really focused on real time, even though there were a couple things there. So if you're interested in checking out the Galileo project, I have the link below up there. However, there was one small nugget of information there that was interesting. They started talking about Airlink, which was their real-time protocol. It was used all the way back on the Zip, and some of that protocol was documented, but not all of it at the time. I assumed that they were just trying to figure out which protocols they needed to reverse in order to be able to capture the information and save those mega dumps, and realized they were going down the wrong path with the Airlink protocol. On top of that, the Fitbit Charge that I had was a little bit different. See, it had notifications and a heart rate monitor on there. So that protocol didn't work quite as described, but it was a pretty good start. Now, as I just mentioned, the Fitbit Charge can get alerts on calls and text, and it can also work on both iPhone and Android. In order to work on an iPhone, though, you have to follow Apple's rules. And as with most things Apple, they're a tiny bit backwards. Instead of the phone communicating to your devices actually need to communicate to your phone. This is called ANCS, or the Apple Notification Center service. It's an interesting way not to tie up the phone's radio, but it's kind of strange concept-wise to wrap your head around and forces your devices to expend a lot more battery instead of your phone expending the battery. So your things need to be charged more often. Regardless, if you want your product to work on an iPhone, you better have that ANCS compatibility. But the problem here was Android phones are not made by Apple, and they don't have ANCS. So what's going on here? Well, ANCS was important because it completely changed the way that all these protocols worked. It depended on it for some reason. And Android gives the user the ability to run GATT servers, unlike the iPhone did at the time. That means on Android, we can run both a GATT server and client simultaneously. So, what did Fitbit do? Well, they made a really derpified version of ANCS in their Android app. So, what did I do? I made a really derpified version of the ANCS server in my Android app. So the ANCS server was really, really, really dumb. It was a singular service that only had 3 characteristics and 2 descriptors, and you can see the basic wiring for it over on the right. They didn't have to really do anything. They just had to be present doing pretty much nothing and saying narf, like Pinky over there. So now that I had the fake ANCS server in place, doing nothing, the Fitbit magically decided to connect to my phone, and somehow a bunch more of my services are now accessible to me. And the Airlink commands are actually being responded to correctly, but the Fitbit still didn't want to give up all of the data that I wanted. In particular, I wanted the heart rate monitor. So things were starting to get a little bit annoying. So I had to get sneaky. Luckily, Android has a great feature to let you be sneaky. If you go into the About Your Phone menu on there and tap the Build button of your phone 7 times, you will get a hidden menu called Developer Options. Go to that menu and enable the Bluetooth host controller interface Snoop log. Then jog over to the Fitbit app, have it report some real-time data, hop back over to that developer option, turn it off, and you get a lovely PCAP file you can load right into Wireshark. Everything looked great until I saw some weird authorizations using some numbers that I didn't have any clue about. And a couple new commands showed up too. So if I want to get sneaky, I have to blend in. Turns out, after a lot of studying, a lot of these numbers stayed the same. It looked kind of like a multi-part challenge response system. So the first thing I did was look at the licensing information for open source licenses in the Fitbit app, and lucky me, I saw that they were using stripped castle or spongy castle. So I combined that with a teardown from iFixit, and the most logical explanation I could think of that it would use was a CMAC through XTEA. And it turns out that that guess was right. So now all we have to do is find out where these numbers actually came from. In order to do that, we had to back that app up. So through a series of trial and error, I found out I could restore the app to the same phone I backed it up from, but not to another phone or the same phone after a factory reset. That meant that the Android ID that's used is used somehow to invalidate or protect the preference data. So Logcat to the rescue here. Fitbit was very helpful in that the decryption error was noted right in the general log. So how was this data eventually protected? Well, there's an unprotected UUID in the Fitbit mobile preferences XML file. It's just some random number. You combine that with your Android ID, and you get an AES key. You run AES decrypt, and you can press X to get the JSON file that has the Bluetooth client authentication credentials helpfully encoded in there. And there are my mysterious numbers. And so I implemented this challenge in here. And if you're interested in some proof of concept code snippets, feel free to ask me about Loom later on in the Q&A. So I can now complete the Mac challenge from scratch. And using mostly the same Airlink protocol that the Galileo project dictated before, I'm able to get some extra data. As you can see from the screenshot on the right, I was kind of just parsing apart different parts of the payload to figure out what bytes correlated to what data in the real-time stream that the real-time app reported, and steps really weren't my priority. But if you look at the last 2 byte pairs, we have the heart rate at 108 or 6C, and then followed by a confidence interval. Now, a very interesting fact is that the Fitbit knows how confident it is about your heart rate. Anything anything with a confidence interval of over 5 will show a dash dash on your Fitbit, meaning it doesn't trust the number that it's giving you. And so you actually are able to know just how confident the Fitbit is inside of what your heart rate is when you report it up to the game. Ah, you need to use the mouse. Thank you. Well, so was this the end of the road? I didn't pay anything for this, and I learned a lot, but was it really worth my time? I actually think it was, because now that I had all of this taken care of, I can stream that information to my server. The PC the game's running on will go ahead and download it, and then that data stream is fed into a custom overlay app, and I can know on screen whether or not I'm in the zone and see my heart rate. Then I can also sideload the calories uh, by segmented by session start and end of the game. And here's our payoff. On the left is a quick screenshot in between, just before starting a song, from the song select screen, so my heart rate was lower and not quite in the zone. And on the right, you can see that I started moving around and my heart rate went up a little bit. But wait, there's more. So back when all this happened, Bluetooth Low Energy didn't used to be ubiquitous. In fact, many phones didn't even have it at the time, and you had to have Android Lollipop in order to do anything. Luckily, Fitbit included a dongle that allowed the desktop app to send Bluetooth Low Energy commands, and that dongle operated via standard HID reports. Thanks so much to the Galileo project for helpfully completely reverse engineering this dongle, because HID meant pretty much universal user space compatibility. And in layman's terms, that means the DDR arcade games run on this ancient, obscure version of Japanese Windows XP embedded. But an HID device doesn't need any special drivers to run. You can simply plug it in there. A custom application was written to basically do the same work as the phone. The user uploads their Fitbit backup into my web portal, their Fitbit's MAC address, and their Android ID. And then on login, my custom application is triggered. It basically takes the place of the phone and tries to connect to the Fitbit. Then everything the phone would normally arbitrate is now sent through that HID dongle without needing the phone at all. Then the data can stream in natively, and I don't even have to trust the user's input by using sideloading APIs that are exposed to them. And that, I can honestly say, is how I hacked my life and got my groove back. Any questions?
There are no questions in the feed yet. If anybody has questions, go ahead and drop them in the talk QA. If anybody for this talk, that's talk QA, getting a pulse on your Fitbytes, and we'll read the questions out so Ginji can answer them.
I do have proof of concept code if you guys are interested in some of that too. So if you want me to pull up any of the interesting bits.
So I do see a couple of people starting to type, but I actually had a question I wanted to ask Ginji, and this came up in one of the event chats around your talk. There are people that are interested in doing something like this with Stepmania and some of the non-official DDR games. Is there? Have you looked into this, or do you know if it's possible using Stepmania or non-official DDR?
Absolutely. In fact, I have a special version of Stepmania I keep on my GitHub repo that has a special Python 3 IO driver to use actual real Konami IO boards and run natively on Konami Japanese Windows XP. So you can run Stepmania natively that way. And I also have a feature called Song Broadcast built into there. And that song broadcast feature triggers my custom application as well. So you can use that overlay with Stepmania if you choose.
Awesome. And then we have a question from Derry Dobby. Is your code available on GitHub?
For Stepmania or the Fitbit application?
The Fitbit application, I believe. And
The
Derry, if
Fitbit,
go ahead and
the
follow up.
Fitbit application, I can't quite distribute it, but I can show you some wonderful screenshots of how it works if you're interested in a particular area of it. I'm not allowed to actually post it, unfortunately, but I have all of it available if you want to see it.
Awesome, thank you. And maybe we can talk about that in the Discord chat afterwards. Are you going to be hanging out after the talk in the Discord?
Yes, just send me an @ and I will absolutely pop over there and answer any questions that I can.
Awesome. And if anybody else has any questions, the QA chat is still open at Talk QA Submissions, getting a pulse on your FitBytes.
All right. So thank you, everybody. That was a wonderful talk. Always interesting. So let's see. Our next is a panel that is going to be starting a career in InfoSec, and that'll be starting right around noon Pacific. And so we're going to go on to an intermission, grab the food, lunch, drinks, take that bathroom break, and have a break. And we'll see you back here at noon.
Do we have time
Bye,
for one
everyone.
more question, Kat?
Oh,
It looks like one
absolutely.
just came in. So one question from Kalu. Where is this customized DDR machine installed?
It is in DeKalb, Illinois, at Star World's Arcade.
And it looks like we actually have one more coming in. If we still have a couple of minutes.
Oh, absolutely, we do.
Okay, they stopped typing. So if we want, we can jump down to the chat.
All right. So we will go to our intermission. Again, questions and discussion can continue to happen in Discord. When you do join Discord, it might take a couple of minutes for you to get the roles to get all of the channels. So just be patient with us, and we will see you there.
Thank you, everyone.